Well, welcome back everyone. Today I wanted to continue with the tutorial series I'm doing on the superheterodyne receiver. So in the last video we covered off on the RF and the mixer stage. So today let's take a look at the IF stage. Okay, so today we're going to continue looking at the superheterodyne receiver and actually looking at how the stages from that block diagram are implemented in real-world circuits. In the last video we looked at essentially the RF stage and the mixing stage, and today we'll take a look at the IF amplifier stage. So I've got another circuit showing at the moment, which is a valve or a tube IF amplifier stage. And if we take a look at it, this tank circuit or tuned circuit here would be the tuned circuit that is in the plate or the anode circuit of the mixing valve. So in effect it's our first IF filter because it's tuned to the actual IF frequency. You'll note that coil is part of a air core transformer, and the secondary is another tuned circuit. You'll also note that it's denoting that the ferrite cores in the actual coils are adjustable, and rather than having trimming capacitors in this case, it's actually adjusting the inductance of those particular coils to affect the frequency that the tuned circuit is tuned to. Now, both of those are going to be tuned to around the 455 mark. In some cases, you will tune for a peak around 455 kilohertz. And in other cases, you may need to extend the bandwidth, so you may tune one side so that its peak is slightly lower than the IF frequency, and you may tune the other side so that its peak is slightly higher. So in effect, you will have a lower overall Q factor. However, it'll give you a wider bandwidth, so higher fidelity signals will be able to be transferred through that transformer. Now, if we look at the second tuned circuit that we have here, you'll note that it's fed, the bottom of it is fed through this 2.2 megohm resistor, and the top part of it goes onto the actual grid of this particular pentode valve. The voltage coming through the resistor is actually from the AGC circuit and is used to automatically control the gain. So if you get a large signal, it will tend to reduce the gain of the IF amplifier so that it doesn't overdrive the whole receiver. The IF signal will be appearing on the valve grid terminal on PID 1. You'll also note that in the anode circuit we have another tuned circuit, which is part of another air core transformer, and again there are adjustable iron cores in the actual inductors themselves, which are used to tune the respective tank circuits or tuned circuits to 455 kilohertz. The rest of the circuitry we have around here in the cathode and the screen grid are simply for biasing the actual valve into its operating conditions. Now, whereas the mixer was operating as a non-linear device so that we actually had mixing occurring, the IF amplifier will be biased into a linear portion of its characteristics so that it is a linear amplifier of the actual signal that's being fed into the grid. Out of the other side of this transformer, we essentially have the amplified IF signal, which contains the AM modulated signal on it as well. So that's a valve version. Now let's take a look at a transistor version of an IF amplifier. So again, on the left side, this coil and associated capacitor is forming that first IF filter, if you like, on the output of the mixer, and it's also part of a transformer. So the IF signal will be coupled through to this transformer and will be appearing on the base of this first transistor Q2. Again, you'll notice in the collector we have another tuned circuit, again which will be tuned to 455 kilocycles, and we have another coil which is coupled as a transformer to that tuned circuit, which is feeding the base of Q3. You'll note that the circuit around Q2 and Q3 is practically the same, and that's because essentially this is a two transistor or two stage IF amplifier. So this transformer in the collector of Q3 is the output of the IF amplifier. And again, the rest of the circuitry that we have here is basically just biasing the transistors into the linear operating zone. So some emitter resistor and decoupling in both transistor emitters, and then we've got some resistors here in the base circuit just to set the device in that linear operating zone. So that's two examples of the IF stage in a valve or tube situation in a transistor stage. In the next video, we'll take a look at the detector and the audio stages. So as always, if you like what I'm doing, please like the video. If you'd like to see more, then please subscribe, and don't forget to hit the bell so you get notified when I've done something new. And you can also take a look at my Facebook page and also my website. Okay, cheers.